Hey everyone, this is Bathymetrics, and today we're doing episode 5 of GridSchool for Bitwig 3.0. All of these episodes in GridSchool build upon concepts and techniques that I explain and describe in earlier episodes of the series. So if you're coming in right now on episode 5 and you haven't seen some of the earlier episodes, I strongly recommend you go find my playlist for all the GridSchool episodes and work your way through from the start so that the things I talk about today will make more sense. You can always find a link to this playlist in the description of the video itself. So today we're going to be talking about ports and precords, which are two very, very specific concepts with some really neat design aspects to them, some really useful and intuitive stuff once somebody has explained it to you. So we're going to start with just ports and understanding ports. Every single device has input ports on the left and output ports on the right. Some devices may have only an output port because they generate or do something all by themselves, so there's no input that affects them in any way. So like some of these I/O modules typically only have outputs of some sort, not an input. The next thing to know is that there's a rhyme and a reason to the color of these ports. Now, you can break rules all over the place in the grid. You can send signals into something that are different than what it kind of expects to have given to it as input, and you can run across some interesting happy accidents by breaking the rules. But as a general rule, it's good to understand what these port colors mean and what type of signal it's really designed to accept and why it accepts that signal. So let's talk about it in the context of an oscillator. Like here's a triangle oscillator, and it accepts 3 different colors or 3 different types of input signal. And then it also sends out an output signal that is red. So what does this mean? Well, you can get a lot of clues from looking at the I/O category. Red has to do with audio. The yellow has to do with note gates, like when you hold down a note, as long as you're holding it down, there's a gate active. In fact, you can even see this light up when I hold down a note. It stays lit until I let go of the note. So there's a gate. It triggers on, lasts for a certain duration, and triggers off. That's a gate. And so gate signals are typically yellow, and connectors that are expecting to work with gates are yellow. Phase is a kind of complex subject that I will be covering in detail, deep dive detail in episode 12 of this series. So I'm not going to go into it too much. I described it a little bit in the previous video, episode number 4. But the basic idea is phase controls the start to end time of a cycle of some sort. It could be the start to end time of a wave in an oscillator. It could be a start to end time of a sequence of events, like here's an 8-step sequence of gates on and off, and they occur over a certain amount of time, and that time is determined by phase. And so that's why it has a purple port for the phase input, and it outputs data or a gate. So the output is yellow. Starting to see a pattern here yet? Orange. Or if we go back here to the I/O stuff, orange is pitch. Pitch. Anything that's orange is kind of designed to accept a pitch value, some sort of MIDI note value. Not hertz, but MIDI notes. C3, C4, B2, so on and so forth. So anything that's orange is pitch. Okay, now this particular blue color, let me delete some of these to just keep things clear. This blue color has to do with controller signals like CC data. So pitch, timbre, and velocity, which are typical types of CC data, are this particular blue color here. And then we see more red colors here. Again, these mean audio signals of some sort. Here's the audio out. Here's a side chain that pulls audio in from somewhere else in the project. Here's a kind of sidechain input that's meant to take audio input from a hardware synthesizer outside of Bitwig that's coming in, through your audio interface card. Here's the hardware out. For Euro racks, we have audio signals that are really voltage signals that are expressed as CV in or CV out. That stands for constant voltage, continuous voltage. I don't know. I don't have Euro rack stuff, but that's what those are for. And since they kind of deal with audio signal of a sort, at least, that's why they're red. And then we have some yellow stuff again, which means it has something to do with gates or triggers, right? So this is saying, is a key on? And, specifically which key on is it? Is someone hitting a G1 note? Well, then this will get triggered. Is someone hitting, let's see what scale my keyboard's in, right? So I'm in a scale of C right now. So if I tap a C note, nothing happens. But if I set this to a C1, nope, C2, C0, there we go. If I hit a C1 note, see how this lights up? So this is just a way to say, is a certain specific note being played? So it's trigger, it's gate, but it's a special kind of gate. So that's the rhyme or reason for all this stuff. Now, the specific colors, I've mentioned a lot of them to you, but there's a couple others we haven't seen yet. One, of course, is this category of envelopes. You'll notice every envelope has this sort of aqua green or turquoise, well, more like aqua kind of green color. And this is, it basically means envelope. This color is associated with envelopes. So when you want to take a signal and apply an envelope to it, you're going to put it into that same color port on an envelope, and the envelope's going to send out an envelope signal. Even though it's going to audio, it's still coming out of an envelope. So the output port is this color to indicate that these are the envelope inputs and outputs. Now there's a couple supplemental outputs to them. One of them is yellow, which means we can have a gate trigger this envelope instead of, well, normally it is a note gate, right, that triggers it. But you could hook up other ways of detecting a gate signal and make this envelope trigger in different ways. And then this blue here, remember you can always select a module and tap F1 to see the help for it. The blue is the actual envelope signal itself. So that's a little weird to describe. The shape of this envelope gets output from here. The value of the envelope gets output here, the kind of mathematical value or the actual, 0 to 100% back down to 0 again is what's being put out of here. And that can be useful for some more esoteric sound design things. This is a pass-through of the audio signal that came into the envelope. This one is just saying, now let me pass whatever the current value of that audio signal is out. So that's the difference in these choices. So that envelope is this color green. Now there's another kind of greenish color, which is the LFO category, or the random category, has the same color that's not quite this green color. It's a little more turquoise, and it's also not the same deep blue as some of the MIDI-based CC type values. See how it's a little different? So again, this is just a color coding telling you we're a little different. We're a different type of signal. And that's what's going on with those. And that's pretty much it. You're not going to run into things other than those several shades of bluish green and red and purple and orange and yellow. As you click through anything here, you can see they've all got certain ports that sort of imply what you should be putting into them and what you should be getting out of them, right? Like, this is an interesting one. If I want to compare two audio signals, that's why the input ports are red, and I want to decide if they're roughly equal to each other, then I'll output a gate or trigger signal, which is yellow, right? And I can use that to drive, for example, the gate on something like an envelope. So again, that's the basic idea behind the ports, is they're color-coded, the colors mean something, and they can give you clues as to what to try to hook up to something like an LFO. Like if you want to say, well, if I want to mess with this LFO and make it do interesting things, and I really don't know what I'm doing, I'm just experimenting, well, look for anything that outputs a yellow port on the other side of it and ask yourself, well, can I do something interesting like that? Can I hook up this gate sequencer to this LFO? And will that affect when this LFO triggers? Like on the first of 8 pulses and the third and the 7th of 8 pulses? Or maybe I want to make this a 16-note pattern. And now it's going to trigger like so. And you can even see the gate out signals coming out of this as it cycles through 16th notes at a tempo of 90. And it's going to make this LFO trigger its LFO shape only when those gates hit, right? So these colors give you a key to understand how to experiment with them. If I were to set a, like a saw wave into here, well, that could do interesting things, but it also might not make much sense. It wasn't really designed to take the input of this module, but you can break the rules, so you can still experiment and see what happens, and sometimes you get some interesting results from doing that. Okay, so that's the ports. Now let's talk about prechords. Prechords are effectively pre-built ports already set up for you. There's a really, really good video in episode 1 or 2. I talk about the videos that Bitwig themselves have put out about using the grid. And in one of those first video or two, Dave Lindenbank says, this very simple structure you see right here, if you as a user had to build every single input and output going between these 3 modules, it would be this complex thing with like 20 different or 25 different modules in it. Like the way we have to build things in Reactor or Max for Live requires you to excruciatingly build everything the hard way. Every single input, every single cable, every single switch, every single bit of behavior on the input, the filtering of the input, the signal routing and switching. You have to build it all by hand around these very basic bare bones generators and filters and stuff. And it's a pain in the butt. It really is. And this is one thing that's brilliant about the design of the grid, is that you can make sound with just these 3 modules. And you can make that sound because of these special things they call prechords. So there's already a pitch key tracking device or circuit built right into every oscillator. That's what this little keyboard thing means. When you light that up, this is automatically tracking the pitch of notes you bring in. So that's all being done by this. If this prechord didn't exist, if I turn it off, I would have to manually do things like, okay, detect my pitch coming in, and let's hook that up. And then now let's, maybe do some other things to that. Let's scale it up or down by a certain number of semitones or, whatever. And it's like you have to start building circuits to do what is just already there automatically if you just turn on the prechord for a given port. So this is the easy mode, is just use prechords. When you want to start doing something fancy, like you say, well, I don't want you to detect that I'm playing C2, and I don't want you to play this at a pitch of C2. Instead, I want to detect that you're playing C2, but then do a bunch of weird games to it, depending on all kinds of stuff, and actually send a different pitch into this oscillator. Well, that's when you would turn off the prechord and start connecting things to this pitch port and telling the oscillator how to react to the signal that's coming in through the pitch port, okay? So that's the basic idea behind a prechord. It's easiest to understand if we talk about pitch. Now, phase, in this particular example, doesn't have a special symbol under it, so if you want to do anything with the phase of this oscillator and, frequency modulate it or phase modulate it, same thing, basically, you would have to hook up some sort of circuit to this phase input and then say how much do you want to scale that incoming phase modulation of some sort, okay? But the yellow one does have a little Prechord symbol, and it's off by default. And this is the trigger. This is the symbol for triggers. And I'm going to get into triggers versus gates in a different module somewhere down the road. Polarity has already done a pretty good video on that. I'm not going to go find it for you, but there's a good video out there that Polarity did earlier this week or last week that kind of explains the difference between gates and triggers if you're in a hurry, but I will cover this later. The basic idea, though, is that a trigger is different from a gate in that it will reset the behavior of something. So there is a trigger input under logic, right? But it's in the logic category instead of the I/O category like a gate, because triggers are meant to basically, under certain conditions, reset other things. And so it's more of a logic function, like when something happens, send out a trigger impulse and reset the oscillator. Well, you've got a built-in trigger on a lot of your oscillators, because in some of my earlier videos outside of the GridSchool series where I talk about voice handling, you can, for example, turn on a kind of simple unison for a voice. Here, how we have a kind of a stereo image now. Left and right are slightly detuned from each other. But if this is selected, every time I toggle a new note gate, it's going to start both of those left and right waveforms in perfect phase with each other and then let them drift out of phase with each other. But if I turn this off, that phase is going to be free running regardless of when and how I hit the note. So if you want a better understanding of that, go look at my earlier videos about voice handling in the regular Bitwig producer tutorial series, and they'll go into that. But that's what triggers are for. Should I reset things or just let them free run? Here's the Prechord symbol for a gate itself, and that's why this sound generator, this oscillator is actually generating a signal all the time. We're going to attach this oscilloscope to it, and let's drag it out a little bit wider so we can see the full waveform. Let's make our chords a little nicer by stretching some things out. Okay, so this triangle wave is phasing because I set it up to run with left and right detuned, and that's why it looks crazy like this. If I turn off the detuning, now we just see a normal triangle wave. Okay, if I skew it, we're seeing what the triangle wave looks like. If I fold it, we're seeing what the folded wave looks like, and so on. So it's always generating. It's always making sound. If you didn't have this gate, this sound would constantly be running out the output like so. So the gate keeps things quiet. The gate keeps things quiet when the signal is at 0, but then when I hold a key down, I basically say, okay, let the signal flow through this for as long as the key is held down. And then that signal is going to flow according to the timing of this envelope. All right, so that's your gate Prechord. And again, if you want to have different behavior than normal, you can turn this Prechord off and you can hook up a bunch of crazy stuff to this input for the gate and decide exactly when and how you want the gate to trigger. Like, I could make a gate sequencer run the envelope. Speed this up so it's a little more distinct. So this is an eighth note pattern, 8 steps at a BPM of 90, and it's just kicking out gates, in this pattern. Right? And now that's what's running the envelope instead of me pressing keys on the keyboard. Right? So that's what's going on here. So this is just your standard when you touch your keyboard, and this is if you want to drive it with other devices. Okay? And it's remembering the last pitch I touched over here, so that's why it's playing a higher note. Now it's going to do a lower note. Now it's going to trigger a lower note. Okay, so that's effectively what these Prechords are. Now, sometimes you can leave the Prechord on and hook something up to the direct input, and it will work correctly whether the Prechord is on or off. But if you leave it on, what's going to happen is if I actually press a key manually, let's turn off some of these. So now I've only got an automatic sequenced gate happening in the first eighth note of the bar, right? But if I touch my keyboard somewhere in the middle, it's going to trigger. That was me touching my keyboard. But if I turn this off, it's only going to play. I'm slapping my keyboard and nothing's playing except the actual input coming from this sequencer, okay? So that's, if you ever get confused by, well, why does it work sometimes when this is on or off or what's going on, that's what's happening is it's like you can manually override whatever circuit you've got driving the input if you also have the Prechord on. If you want to make sure that what you do manually on your keyboard or your controllers doesn't affect the more mechanical or sequenced or mathematical inputs you're trying to use, you always want to make sure to turn the Prechord off, okay? So that anything you do manually isn't affecting the automatic stuff. And let's see, that's pretty much it. I mean, there are other devices that have Prechords. This purple thing here is a Prechord for phase. And specifically, it's saying, what is the phase of the sequencer itself, the DAW transport? I'm at a BPM of 90, and every time I press the transport button, it's sending out a full phase each bar. Every 8 eighth notes or every 16 16th notes, so on and so forth, I am doing a phase from start to finish and then restarting again at the beginning of the phase. And so that's how a sequencer works. It's driven by the phase. This is broken up into 8 steps, so it's 8 chunks of a bar or eighth notes, right? And you could, for example, take a special LFO called transport that outputs phase and use that to drive this thing. And right now it's set to 1 bar. 16 16th notes means this is going to move along at the same pace that it did when I have this Prechord triggered, because it's the pace of the DAW itself and its current signal. But I could, for example, bring this in here and say, run it twice as fast by triggering twice as fast by running it at a pace of 8 over 16 pulses of the bar. So I'm basically doing double time here. And if I were to set this to 32, I could make it run at half time against the normal beat or measure or cycle time of a bar at the project tempo. So then I could be using this to drive an envelope at a different rate than normal, right? So that's what this stuff's about. And let's turn all that off because it's annoying. So that's pretty much it for the Prechords. If you see a little special symbol of a certain color, it's meant to override. If you turn it off, then you have to set up your own circuit to drive the input. But if you turn it on, then whatever's driving the input may also work, but you can manually override it. And if you don't have anything hooked up to the input at all, then you're going to need to have this button lit to do anything at all. Like, see, if I turn off this phase, this sequencer isn't running anymore because there's nothing driving it manually, and I've turned off the Prechord. So for this to pick up the phase of the project that's being sent into the polygrid module, I have to turn this on and say, detect that phase, and just run this at the phase of the project itself. Okay, so that's pretty much everything about ports and Prechords. I'll see you in the next video. Thank you.